Hi, Dave Scranton here with City of Portland Electrical Inspections, here to take a look at a 200 amp service. So let's go ahead and dive into it. So here we have our meter. Utility typically requires that they locate where the meter goes. Usually they want it in the front 10 feet of the building, closest to where the drop's coming from the street. So we don't necessarily regulate that. That's a power company requirement. So we're assuming they told them to go ahead and put it here. They also have a requirement for heights to the center of the meter. No lower than 4, no higher than 6, so they have that. We can see our mast going up. They have their hub and their mast up, their strap. We are over a driveway, so the height requirement for a driveway is at least 12 feet, and we do have that to the service drip loop, so we're okay there. You can see that the mast extends quite a ways above the roof, and they have what's called a guy wire kit attached to the mast, and so that's another power company requirement. That way when they have their drop attached to it, it doesn't bend that conduit over. So that's the guy kit there. The one thing I don't see up there is on the neutral wire. They need to identify the neutral, and they haven't done that, so that would be a correction. So other than that, let's go ahead and take a look in the meter. Okay, as we open the meter, we can see that they did identify the neutral going into the panel, and they are actually required to identify the neutral in all of the locations, so they'll need to come back and throw on some more white tape to identify the neutral. Okay, I don't know if you can see it or not, but there is some grease. I call it grease. It's actually a no-lox inhibitor for aluminum wires. It's a compound that helps stop the corrosion or the oxidation of the aluminum wire, and that's required on all aluminum connections. And so they do have that. And we want to check our connections for tightness, and it looks like we're good there. So and we can see they've nippled into the panel that's directly behind here, so we don't need a main breaker out here. And that's pretty much it for out here. So let's go see what we see inside. Okay, inside to the panel. One thing we will always take a look at for panels, where they get installed. There's a couple places we can't install them. One is in a closet. They can never go into a closet, and a bathroom is another area where you can install a panel. So we don't have that problem here. Another thing you always want to be aware of is the working clearances at a panel. We need 30 inches wide, and 30 inches, just as long as the panel fits in that 30 inches, you'll be okay that way. Then the other thing is 3 feet in front of the panel. So for that 30 inches and 3 feet, we cannot have anything in that area that's going to impede access to the panel. Okay? As we open the panel, we can see there's a couple branch circuits already installed, and you can see that they have them labeled. So they do need to be labeled. This one gives a west receptacle, and this is an east receptacle. So they've kind of given us a reference as to where the electrical items are that they're listing on the breakers. So so far everything looks good. Let's go ahead and open it up and see what we see inside. Okay, so the first thing we want to see is the conduit system they used to come into the panel. They did use metallic conduit, so because of that they actually need to ground that conduit, and they do that with a bushing in this particular case. There are other methods that could be used for that, such as a grounding wedge or a grounding lock nut. At any rate, they used a grounding bushing and then ran a ground wire to the ground bus. Now that wire is sized per the size of the incoming conductors, and currently they don't have the right size of wire, so that's going to be a correction. For a 200 amp service, that needs to be at least a number 4. It looks like we have a number 8 or maybe number 6, so that will be a correction. The next thing we want to see is, you can see it here, there's a connection right here. This is how that's their main bonding jumper, and that's how they bond the service to the can and to their grounding electrode conductor. which we will see in a moment. Okay, we talked about the inhibitor, the no-ox antioxidant. They also have those connections on these connections in here. The connections are tight, so we're okay there. You see the branch circuits coming in. They use the appropriate connectors on that. Connections are good and tight. They did use the correct brand of breakers for the panel. Some panels do have interchangeable breakers with other brands, but they are pretty specific to the brand of the panel. And actually on the panel itself, there's all kind of literature on here that tells you which breakers you can use in this panel. You do need to follow that information. They also have catalog numbers for various accessory parts that you need for the panel, and that information is also on the cover. So we were talking about the grounding electrode. So that's this wire here. And we can see they drop down and they run around the room and they pop outside of some ground rods. So we will go take a look at that. And this particular structure doesn't have any water or gas piping in it, so there isn't anything to ground on that. So let's go ahead and jump outside and take a look at their grounding system. Okay, so we're outside now to take a look at their grounding electrode system. In this particular case, we have a couple ground rods. So as we pan down here, you can see the wire coming out of the building, and it goes down to this first ground rod, and it has an appropriate connector on it that's approved for ground rods. And they do make various types of connectors, and you need to make sure the one you use is approved for ground rods and that it's installed according to the manufacturer's instructions. So for this particular one, it is an approved connector and it's installed correctly. And then we can see the wires looped through this connector and running over to the other rod. That second rod is required if this rod doesn't give you 25 ohms of resistance or less. You're required to supplement it with another rod. So typically folks just put in two rods and avoid having to do that test for the ohms check. So the one thing I do see here is that ground wire, that would either need to be attached to the building between the rods, or typically what we see is it gets dug in the ground a little bit so it's protected with the soils. So that would be a correction to have them attach it to the building or bury the wire between the rods. Again, the rods have to be at least 6 feet apart. They should be driven flush with the ground or just below grade, but they do need to be accessible like these are for inspection so we can see them.